today. This is inshallah today we'll be starting chapter 2, which is we'll be talking about fuel types, the different fuel type for the different application, like gasoline engine and diesel engine, and we'll be talking about the properties. So inshallah today we'll have just a brief about the petroleum crude oil. I think you are aware about that. We'll be talking about the most common fuels that are in application, either actually in gasoline, diesel engine, in the vehicles application, or also in the industry. What kind actually of common fuels are there in the application? We'll be talking about the molecular structure of the different fuel and how actually we can classify the fuel under different families. They are almost actually alkyl groups. So inshallah we'll see the different families of the fuel, so that when you hear actually a name of the fuel, you should be actually able to classify this fuel under a given family, and they should be actually able to translate this actually to the chemical structure of this fuel. What is the number of carbon atom? What is the number of hydrogen atom in this fuel? Is it heavy fuel, light fuel? Is this reactive? Is it actually, does it result actually in more emission or less emission? So inshallah we'll be talking about all of this. We'll be talking about some general properties for any fuel that should be there in any fuel. And then we'll be talking specifically for the fuel for gasoline engine. We'll be talking actually for isooctane. And we'll be talking actually about the octane number, which is actually a measure of the quality of the fuel, the octane number for the gasoline engine. And then we will relate actually this octane number, the value of the octane number, with the phenomena which is the engine knock. So engine knock, shabab, is related to, most probably it is related to the gasoline engine due to the self-ignition of the fuel. That's why we have the octane number, which gives us indication about the resistance of this fuel to the self-ignition, and the resistance to this fuel actually to have knocking, to have engine knock or noise in this case. Also, we'll be talking, inshallah, about the properties of the diesel fuel, dodecane fuel. We'll be talking about those properties, and also we will be talking actually about the quality number of the diesel fuel, which is the cetane number. So cetane number is used for the diesel fuel, and the octane number is used for the gasoline fuel. But up to the moment, shabab, before we proceed, do you have any question for actually what we have talking about before? In chapter 1, we talk about engine type, engine parts. We talk about the difference between diesel and gasoline engine, and we talk about 2-stroke and 4-stroke. All of this we have actually presented in chapter 1. Do you have any question? Anything is suspended? Have you started preparing the presentation? Do you need any help? So I have to hear from you, not just giving the lecture and then we can leave. So do you have any input, please?
Yes, Doctor.
Yes.
So please, Doctor, can you give a brief discussion about the 2- and 4-stroke engine? Just a summary.
As a summary for 2-stroke and 4-stroke?
Yes.
So we... Yes, Yazid, do you have an input as well? Yazid?
Yes, Doctor.
Do you have an input? I just see
an
you.
Input? مش سامعك يا دكتور.
I just see you unmuted. I just heard that you want to say something or anything. Do you have anything you want to ask about?
Yes, my question was about if you can give us a summary about 2- and 4-stroke engine.
So yeah, so it seems I was just conflicted with someone else. That is the case, Shabab. So anybody else have any question? Have any comment, or most of you actually didn't even start trying to revise what we have done? I know we are at the beginning and you just need some time. So inshallah we'll have a quiz, Shabab, next Wednesday. So try to be ready. I'm not asking you just to memorize everything. I'm just writing advantage, disadvantage, comparison between spark ignition and diesel engine, and I have listed all of this data, but just this is actually for your knowledge. I will be asking about the specific things that actually it checks that you understand the main difference. I will not be asking you to write down paragraphs and all of that. No. Okay, this is not the case. So the main difference, Shabab, between 2-stroke and 4-stroke engine. 4-stroke engine complete one cycle in 4-stroke movement of the piston. So the piston first move down in order to have the intake air plus fuel, suck air plus fuel. Then the piston is moving up to compress this air plus fuel. And then we should have combustion by the end of the compression stroke. Then we should have the power stroke. Piston will be moving down. This is the 3rd stroke. And the 4th stroke actually will be the exhaust stroke. Now, if you look at the shaft movement, for each 2-stroke of the piston going up and going down and getting back up, it will be 1 revolution for the crankshaft. And actually for 4 strokes, that means we should have 2 revolutions of the crankshaft in this case. So the system, the engine in this case, complete 1 cycle. 1 cycle, ya shabab, means starting from taking the fuel plus air until we burn it and we have the exhaust gases leaving the engine. And then we repeat this cycle, continue repeating this cycle. So if this cycle is completed in 4-stroke movement of the piston, going down, up, then in this case we call actually this as a 4-stroke engine. In case of 2-stroke engine, it complete actually the cycle in only 2-stroke movement of the piston. While the piston is moving up, in this case, in case of 2-stroke, we don't have valve for the intake valve and the exhaust valve. Just we have port. Just we have side opening for the piston from both sides. Port from here, this is the intake port, and another port actually in the side of the piston, this is the exhaust port. Okay, and while the piston is moving up and down, it just cover and uncover the intake and the exhaust port. Okay, so that we can, in this case, actually, while the piston is moving up, in this case, we can combine the 2-stroke in 1 stroke. We can combine the intake stroke plus the compression stroke in 1 stroke. Let's look here. I can just open with you. This is chapter 1. Let's open it. So here it is, Shiva. So while the piston is moving up here, we have actually, it takes at the beginning of the compression stroke, we have this intake port is uncovered and some air plus fuel will get inside the piston and then it will be compressed. So while the piston is moving up in this case, we have both. We have the intake stroke plus the compression. And then while the piston is moving down, we have the combustion have started. When the piston at the top dead center, combustion start, then we should have the expansion stroke. While the piston is moving down, then in this case, we have expansion plus the piston will uncover the exhaust port. Then we'll have also the exhaust port while the piston is moving down. So in case of 2-stroke, while the piston is moving up, we have intake plus compression. While it is moving down, we have in this case expansion plus the exhaust stroke. That means, Shabab, for each cycle, the 2-stroke engine for each 2-stroke, the 2-stroke engine will complete this cycle actually in 2-stroke movement. That means the cycle will be completed for only 1 revolution of the crankshaft. That means it will repeat the cycle and take fuel again for each 1 crankshaft revolution. But in case of 4-stroke, it produces power actually for 1 cycle for each 2 revolution of the crankshaft. So the 4-stroke produce 1 power stroke for each 2 revolution. 2-stroke produce actually 1 power stroke for each 1 revolution. That means the 2-stroke engine is more powerful engine than the 4-stroke because it can produce double of the power of the 4-stroke engine. But the 2-stroke engine, Shabab, has different problem. You can see here we have intake port and exhaust port. Most probably they will be open for long time actually at the same time. Here the intake port is open, the exhaust port is open. That causes actually losses of the intake charge. Some of the intake charge, fuel plus air, will be just short-circuited and it will be leaving the engine in this case. So the fuel economy in case actually of 2-stroke engine is less than the case of 4-stroke engine. But the engine is powerful engine compared to the 4-stroke engine. Is that answer your question, Yazid, or do you asking about something specific?
It's clear.
Okay, so yeah, just to try to go through the audio, the video of the lecture that we have already recorded. Then inshallah we can you can move further. If you have any question, you try to contact me. I'm available here anytime, even on Friday. I will be in my office. So yes, yes, Mustafa.
Yes, I have a question about the valve lead and the valve lag.
Yes. Valve lead, this is يا شباب at low speed, at engine low speed, we need the valve, the intake valve, to open actually for a short time and a short distance, short lift of the valve. And at high speed, we need actually more air plus fuel. So that means in this case, we need the intake valve to open actually for longer time, and it should have actually longer depths inside the cylinder to allow more air plus fuel to get inside. Because at high speed, we need high power.
Okay.
In this case, if you look at the design of the internal combustion engine, the camshaft, those intake and exhaust valve are opening using camshaft. And this camshaft from the cam design, we cannot change actually the timing of the valve. It cannot be advanced, it cannot be retarded in this case. Here we have, this is the cam, it is opening. Once the tip of the cam is coming, pressing, it will open and it will close. That will not be changing actually at any speed. Just the camshaft will open the valve one time, the same distance for each cycle. What should we do in this case, شباب? At high speed, we need more air plus fuel. We have to open this intake valve actually for longer distance and for more time in this case to have more air plus fuel. And this was, شباب, the system invented by Honda, one of Honda engineer. We call it VTEC, which is a variable valve timing lift. In this case, we have 3 cams connected together. This يعني an engine of 2 intake valve and 2 exhaust valve. In some engine, شباب, they use more than 1 intake valve in order to increase the charge to the engine, increase the amount of air plus fuel. Here you can see this cam. The 2 smaller cam will be opening the intake valve at the normal speed, and this will be actually the small lift, the normal lift. Okay. At higher speed, the engine oil will actually increase. The oil pressure will be increasing, and it will force actually this pin in order actually to engage the central big cam with the other 2 cam at high speed. And look here, at high speed, the central cam will be opening the valve. So the valve lift will be increased in this case, and the amount of air plus fuel will be increased. This is a YouTube video, شباب. It will show you one of the Honda version car. Through this link, you can look exactly how it looks like in reality, those cams. Is this your question? Or valve lead بقى يا شباب, this valve lead is something that we have to open the intake valve not at the top dead center. We just open the intake valve before the top dead center while the exhaust is through, to allow actually more charge of air plus fuel to get inside the engine. And even it will be opened through the suction stroke while the piston is moving down from the top dead center to the bottom dead center, and it will not be closing by the end of the suction stroke. No, it will be closing after the bottom dead center to allow more air plus fuel into the engine. This is very important, يا شباب, لأن at high speed, usually the time for the air plus fuel to get inside the engine is very small, very limited time. Then in this case, we have to allow the intake valve to be opened for longer time in order to have more air plus fuel. Like this, the exhaust valve open before the end of the expansion stroke. First of all, to have high pressure, to make sure that we have high pressure inside the cylinder, so that the gases, when the exhaust valve is open, can leave the engine. This is one reason. The other reason is to open the exhaust valve for longer time in order to make sure all of the exhaust gases has left the engine. Because if we have some residual gases, يا شباب, inside the engine, this actually will adversely affect the combustion process. The efficiency of combustion will be reduced because we have residual gases. It will not be reacting, just it will suppress the reaction and it will reduce the efficiency. Is this an answer to your question?
Yes, yes.
Okay. Any other question, يا شباب? Let's move for today's class. Inshallah, I will be starting just with the introduction to the crude petroleum oil. The crude petroleum oil, as you know, this is coming actually from fossilization of organic matter underground. And usually we call them the hydrocarbon fuel because the component, I think you are aware about that, the component of the fuel are mainly carbon plus hydrogen. And we should have actually some other impurities, including oxygen. We have also some sulfur and some mineral and other actually component. But we have actually to clean up this fuel before using it, and especially sulfur, we do have different kind of purification processes actually including the desulfurization processes actually and washing, grinding, in order actually to clean up the fuel before using actually in any application. We have different fuel, or the fuel can be existing actually in the different phases. It can exist actually in the solid phase. We have the fuel which is cool, we can have wood and some kind of biomass, solid biomass. This is actually the solid form of the fuel. Fuel can also exist in the liquid form, like most actually of the grades of the fuel, like the gasoline engine, kerosene, diesel, fuel oil. All of these are actually liquid fuel. Also, the fuel can exist in the gaseous phase, and we have some important fuels actually in the gaseous phase, like the natural gas and liquefied petroleum gas, and different actually, and also synthetic gas. Synthetic gas actually is a gas that is already created from upper grade of fuel, reducing actually the upper grade fuel to lower grade one. Synthetic gas is a mixture of carbon monoxide plus hydrogen, and it is actually a product also of the refining process that we are going actually to talk about. But actually, Shabab, solid fuel like the coal, this is a dirty fuel. So it has been banned actually in different countries because actually it results in a lot of emissions. And actually should be aware actually about the global warming issue. So those actually emission, they form what is called the greenhouse gases, which form actually a kind of layer around the earth and result actually in what we call the global warming. So the global warming issue, Shabab, if we can say this is actually our earth, and let's say this is the sun, and we have the energy is coming from the sun here. This energy should be actually passed to the earth. Part of this energy should be absorbed here on the earth for the different process and life, and actually the remaining energy should be reflected back to the space. But actually, due to the emission of greenhouse gases, in this case, actually those greenhouse gases forms a layer around this earth. So this layer actually is a layer of greenhouse gases. Those greenhouse gases, Shabab, the main contributor for the greenhouse gases is carbon dioxide plus NOx emission, which is actually NO plus NO2. And also we should have actually methane also is one of the main contributor actually to greenhouse gas emission. Methane can be emitted, Shabab, from the oceans and all of that. And also it can in the industry as well, we may have some leak actually of the methane. Methane is one of the main component actually of the greenhouse gases. But the main contributor to the greenhouse gases is actually the carbon dioxide due to actually burning fossil fuel. So those greenhouse gases forms a layer around the earth, and it prevents actually this energy to be reflected back to the space. And that's why we have what is called actually the global warming. It will heat up actually the earth. And what will happen, Shabab, if this earth actually got heated up? So what will happen to the ice at the polars here? Ice will be what, Shabab? Will be melted and it will be converted to water. And this actually should be resulting actually in the increase of the water level in the sea and the ocean, and some actually low-level countries, you can say like Netherlands or something, it should be disappearing actually by 2050 unless they have a treatment for this issue. So this is the issue of the global warming due to the emission of the greenhouse gases. Mainly the main contributor is carbon dioxide that is emitted to the atmosphere, and it can just create a layer around the earth that actually prevents the energy to be released actually from the earth to the space, causing what is called actually the global warming. That's why, Shabab, there is research is going actually in carbon capture technologies. This is actually one of my point of research. We have different 3 carbon capture technologies. We need to take this carbon dioxide resulting from the combustion process. We need to capture it and prevent it actually from being released to the atmosphere. One of the main carbon capture technologies is the combustion actually using oxy-combustion. So when instead of air combustion, Shabab, air contains O2 plus N2. So N2 usually results in NOx emission, which is NO plus NO2, because this N2 dissociates at high temperature, and it will be forming actually NO and NO2 depending on actually the combustion condition. Those actually NO and NO2 we call them the NOx, which is actually one of the greenhouse gases contributor. But what will happen actually if I burn it with only oxygen, pure oxygen? So burning hydrocarbon with oxygen, burning the carbon with oxygen will result in carbon dioxide, and burning hydrogen in the fuel with oxygen will result actually in water vapor. So the oxy-combustion process for burning actually the fossil fuel hydrocarbon fuel with only pure oxygen will result in carbon dioxide plus H2O. We can condensate H2O, then we can actually capture this carbon dioxide from the exhaust of the system. Capturing this carbon dioxide, we can take it and we can just either we can utilize it to have actually some useful material. We can convert it to carbon dioxide through a hydrogenation process. We can convert it actually to methanol. I think the chemical engineering guys here, you should be aware about that. Hydrogenation process, it is a catalytic reaction of carbon dioxide plus hydrogen, then we can convert it to methanol. I think there is a factory here, big factory. It is a big one in the world. It is existing in Al Jubail for the conversion of carbon dioxide. It can convert it actually to useful actually product like methanol. This is existing in Al Jubail. Another use, we can convert this carbon dioxide into other components like plastic. We can convert it into urea. So those are actually the utilization of the captured carbon dioxide. We need to capture it before being released to the atmosphere and causing the global warming. And that's why we have the Paris Agreement that we should limit the emission due to the combustion of fossil fuel, so that actually we can limit the global warming to be below 2 degrees C by 2050. We should not have actually 2 degrees C rise in global temperature before 2050. And this actually all countries are forced actually to use technologies that either renewable, we don't have emission, or if you're still using fossil fuel, you have to apply some technologies like carbon capture technologies in order to capture the carbon dioxide in this case. So the utilization of carbon dioxide can be converted to polymer, can be converted to plastic, polymer can be converted to plastic, can be converted actually to methanol through hydrogenation reaction, it can be converted to urea. Urea is used actually in agriculture application as a fertilizer. So also carbon dioxide can be converted to this. Also carbon dioxide can be used for enhanced oil recovery. We can inject this carbon dioxide in the oil well, which are close to be empty. Then in this case, it can enhance the recovery rate of the oil in this case. But yeah, enhanced, I think Aramco have already, one of the field has already tried the enhanced oil recovery using carbon dioxide. But usually يعني هي يا شباب ما شاء الله يعني the oil wells they don't need actually enhancement. They are just flooding, so they don't need enhancement. But this is actually application is already existing in different countries. Also, they can use the capture carbon dioxide and they inject it underground. So that this is, we call it the sequestration of the carbon dioxide. And also Aramco has tried this in some location here. They take this carbon dioxide and they inject it underground in order actually to capture this carbon dioxide. Okay, is this idea, Shabab, about the issue of the global warming and the carbon dioxide? Just this is something outside, but you should be aware about. Okay, are you following, Shabab? So let me check here. Said, are you following? Said, okay, so just I'm making sure Shabab that you are all following. Anyway, Shabab, this is just a brief introduction about the global warming issue and the emission due to the combustion of the fossil fuel. The refining process, Shabab, for the crude petroleum, in order actually to get the different grade of fuel, usually they use the distillation curve to separate the lighter component first. Distillation, Shabab, usually it is vacuum distillation. Usually they create vacuum here. Why we create vacuum, Shabab? The distillation, we add heat to just actually heat up the crude petroleum oil. Then the light component will be evaporated. Then we can pass them through a water bath here to condense. Then we can collect this fuel. At a given temperature, some fuel will be collected. At higher temperature, then we can get actually heavier fuel, and then we can collect. This is a separation. But why we prefer actually to use vacuum distillation? Why we should create vacuum here while heating up the oil? So Hassan Banwir?
Yes.
So here, Shabab, we create this vacuum because actually creating a vacuum of any substance should reduce actually the temperature at which actually this liquid can be converted to the vapor phase. Like actually the water. Water at atmospheric temperature, at atmospheric pressure, it actually boils at 100 degrees C. But if we reduce the pressure of the water, then in this case, the water will be boiling at lower temperature. So the idea here to have vacuum pressure inside the distillation curve in order to reduce actually the boiling temperature, so that we can save the energy here, because this is actually a thermal heating. So we need to reduce the temperature at which we have boiling. Then in this case, by creating vacuum, then we will actually reduce the amount of heat required in order actually to evaporate this fuel. So the first process, Shabab, of refining, it should be the distillation, the separation of the lighter component. Then we should have catalytic cracking for actually the heavier component. Then will be separated actually from the refining process. And we should have also a process, we call it actually the reforming. Reforming, Shabab, is converting the heavy fuel into lighter component. Like converting, let's say, methane, CH4, we can convert actually to synthetic gas. So those steam reforming. In this case, methane, ethane, propane, even naphtha, all of the high-grade fuel, higher hydrocarbon fuel. Higher hydrocarbon, Shabab, means we have higher number of carbon in the fuel. We can crack them and reduce them actually to low carbon fuel. Low carbon fuel like the synthetic gas through the steam reforming process. The simplest steam reforming process is the steam reforming of methane. We react methane with steam, H2O. This is a catalytic reaction, Shabab, and it is endothermic. In order to convert this methane CH4, we can convert it actually to a mixture of hydrogen plus carbon monoxide. But why we are converting actually the heavier grade to lighter grade of fuel, Shabab? This is in order to reduce the number of carbon atoms in the fuel, so that when we burn the fuel, we have actually lower emission of carbon dioxide. This is actually the main greenhouse gas in this case. And if we are able, Shabab, to convert all of the fuel, convert it to hydrogen only, that will be the perfect situation. Because in this case, burning hydrogen with oxygen will result actually in water vapor. So this is a very clean water vapor, not only water vapor, okay? And there is a trend, Shabab, to convert the heavy hydrocarbon, convert it to lighter hydrocarbon, or actually the ultimate goal actually is to convert all of the fossil fuel, if we are able to convert them to hydrogen through steam reforming and the gasification reaction. That will be the ultimate situation, because hydrogen can be used as a very clean fuel, can be used. There is also a trend to convert all of the gas turbine in the industry to work with hydrogen. This is the ultimate goal of the gas turbine. And also for the cars. Now, Shabab, in the vehicle, I think they have started a project in Egypt to convert all of the car actually to work with natural gas. Natural gas is mainly methane, CH4, instead actually of benzene, which is isooctane, C8, H18. Very heavy fuel. To convert to work with natural gas or methane, this will result actually in lower emission in this case. And this is the global trend to convert the car in order to work actually with or lighter fuel in order to reduce the emission. And also there is the research ongoing to work on the fuel cell car. I think Toyota already released different version working with the fuel cell hydrogen electric vehicle. We take this hydrogen in the fuel cell, its efficiency much more efficient when we use hydrogen in the fuel cell to produce electrical power, and then we can run the car using the electrical power. This is much more efficient, almost it is double efficiency when we use the hydrogen and burn it inside internal combustion engine. So this is also one of the trends that we have to use the lower grade of hydrocarbon fuel in order to reduce the emission. And there is a trend, Shabab, to convert all of the fossil fuel to hydrogen. And there is a great investment here in the kingdom for this conversion process. We have to reduce the fuel to lighter fuel, then actually we can reduce the emission in this case. Here, Shabab, are the most common fuel, as we said, coal, which is a mixture of all of the components. It is a dirty fuel, it contains the carbon, varying amount of hydrogen, oxygen, nitrogen, moisture, sulfur, whatever you imagine will find in the coal. It's a dirty fuel and it has been banned in different countries. Liquid hydrocarbon fuel, like most common fuel, we have gasoline fuel, we have diesel fuel, alcohol fuel. Alcohol can be produced from the refining process, but usually they prefer to use in perfume and all of that. They are actually sold at high price. So usually you will not find alcohol everywhere. It can be also produced actually from renewable sources. We call it bio, in this case, biofuel. From some plants, actually, you can reduce alcohol. Natural gas, which mainly consists of methane, is one of the most important fuels, natural gas. I think the kingdom here has converted actually most of the gas turbine and the boiler in the industry for the electrical power production have converted great portion of it to work with natural gas instead of heavy fuel. I think 40% of the electrical power produced in the kingdom is coming actually now from natural gas, and it is expected actually to increase this percent. So the trend is to use the lower grade fuel so that we can reduce the emission in this case. Okay. طبعا the use of renewable energy is one of the potential investment here also in the kingdom, but you know there is already oil. We have to use this oil. So I think now the kingdom, they have already prepared a plan for the oil for the next up to 2040. I have received an email with some information like this. They are expecting actually the oil production rate, and what the kingdom should be doing actually in this field. They have to invent actually not too much in the renewable energy, but it has to invest actually in the clean combustion, like production of hydrogen, converting actually the crude petroleum to hydrogen, and the use actually of lighter fuel, like actually natural gas, which is actually the main gas, very important gas in this case. It consists mainly of CH4. Only we have one carbon atom, so it will result actually in lower amount of carbon dioxide in this case. And I expect actually the natural gas to be the main contributor for the electrical power production in the kingdom. Now it is 40%, but it will be increased. I think it should be approaching maybe 70% or something until 2040. Type anyway, natural gas is mainly methane, but we can have some other impurities like what you can see, ethane, propane, butane, some N2 and some other component. It is used in the industry in the gaseous phase, and it can be used as a fuel for the vehicle. Compressed in the gaseous form. It can be compressed in the gaseous form for pressure from 150 to 250 atmosphere. We call it compressed natural gas. And as I told you, there is a trend to convert the car to work with natural gas. It can be also liquefied, and we call it actually in this case liquefied natural gas. But to liquefy the natural gas, it has to reduce its temperature to minus 162 degrees C, okay, in order to convert it to the liquid. This is for exporting the natural gas. In order actually to store bigger amount, we have to convert it to the liquid phase in order actually to export it inside ships and all of that. It has a reasonable heating value, about 15 megajoule per kilogram. We have different fuel also, which is liquefied petroleum gas, LPG. LPG is mixture of about 50-50 propane plus butane. And it is used in the industry in some boiler application, and it is used actually at homes. You see the bottle at home for the stove. This is actually liquefied petroleum gas, which is a mixture of propane plus butane. And it has also very similar actually heating value. Heating value, is the energy content in the fuel per kilogram of the fuel. It is about 50, very, very close to actually to the gasoline and the diesel fuel. The producer gas, or we call it the synthetic gas or the syngas, this is a gas that is created actually from the reduction process of higher hydrocarbon. We can convert it to lower grade hydrocarbon. Like as I told you, the steam reforming of methane. We react methane with steam, some water vapor in the presence of catalyst, and it is endothermic reaction. It needs some heat actually to have this reaction. So we burn some methane in order to generate this heat. Then we can convert this methane into mixture of carbon monoxide plus hydrogen, which is a light fuel, and it will result actually in lower emission. But usually this process reaction results in carbon dioxide, and usually nitrogen will be there because nitrogen is in air so it will be there in any process. That's why شباب the synthetic gas composition, the composition of the synthetic gas will be different from one to another. It is not fixed in composition because actually it depends from which source we get this syngas. If we got it from methane, the composition will be given certain composition. If we got it from propane, from even we can get actually the gasification process, we can get it from coal, from different kind of coal through the gasification process. Gasification also and the steam reforming. It is very similar to the steam reforming process. We can convert the coal into syngas, but in this case, the composition of the syngas will be totally different from actually the syngas produced from another fuel. So it has wider range of composition. Here شباب is natural gas. Natural gas have different grades. Natural gas consists mainly of methane. So as the concentration of methane increases in the natural gas, that means actually this is higher quality natural gas. If the concentration of methane has been reduced, that means actually this is a lower grade of the natural gas. So we have different grades A, B, C, D for the natural gas. Like this also the synthetic gas. We have different synthetic gas. Usually the synthetic gas are generated from the gasification of coal. And as I told you, in some cases we convert the heavy hydrocarbon fuel like methane, methane is not heavy, like propane, butane, the upper grade actually of the heavier hydrocarbon fuel you can convert them to synthetic gas. But most probably we have this conversion process to synthetic gas from the coal. We have different kind of coal. From bituminous coal, this will be the concentration of the synthetic gas produced from this process, steam reforming. It will be 14% hydrogen and 27% carbon monoxide, and some other actually impurities. We have what we call the carbureted water gas. This actually synthetic gas is the same as this synthetic gas, but we add additional reaction. This reaction is called the water gas shift reaction. Water gas shift reaction is the conversion actually. We take this carbon monoxide produced here in the producer gas, we just react this carbon monoxide with the steam back, then it will result actually in more hydrogen plus carbon monoxide. So we convert part of the carbon monoxide in the synthetic gas, we can just react it with the steam. This is, we call it water gas shift reaction, then it can convert actually hydrogen plus carbon monoxide. And that's why in this carbureted water gas, synthetic gas, you will find here the concentration of hydrogen has been raised to 40%. From 14%, we can raise it to 40% due to the addition of this reaction. We call it the water gas shift reaction. Okay, and there is also another synthetic gas from the coke, فحم الكوك. This is also can produce actually this synthetic gas, and this is the composition. But the main component of the synthetic gas are carbon monoxide plus hydrogen. Okay, type is the families of the fuel. The molecular structure of the fuel is hydrocarbon. The fuel is consisting carbon molecules plus hydrogen. And most of the fuel, actually hydrocarbon fuel, are, we call them as alkyl compound. So the name of the fuel, any fuel should have a name. The name is starting with prefix. This prefix gives indication about the number of carbon atoms in the fuel. And it should have suffix, the end of the name, that indicate actually at which alkyl group we classify this fuel. So if the number of carbon atoms is 1, we call actually the prefix should be mis. Number of carbon atoms is 2, we call it S. 3, we call it probe. I think you are aware about that. Are you aware about that? About those names?
Yes.
So I think this is something very simple. And so on. So this actually prefix, the start of the name, give us indication about the number of carbon atom, and actually the last of the name, the suffix of the name, should give us indication about the alkyl group. The fuel can be either having the chain structure, either saturated we don't have double bond, unsaturated we do have double bond, and it can be also in the ring structure. The carbon atoms are connected in the ring structure in this case. And that's why we have the fuel isomer. Isomer mean actually we have a fuel of the same number of carbon atom, same number of hydrogen atom, but it have actually different structure. It can be either a chain structure, saturated or unsaturated, or it can be ring structure. But it should be the same number of carbon and same number of hydrogen in the fuel, but it have different structure. We call it actually isomer of the fuel. Like when we say isooctane. Isooctane, it is octane, C8H18, but actually it is not a chain structure. It has actually different structure. Okay, but different structure شباب will result actually in different combustion properties. طيب the families of the fuel, are you aware يا شباب about the families of the fuel? Aware about it? Paraffins, alkenes, and their chemical composition. Are you aware about that?
The chemical students, yes, but we don't
So,
know about mechanical.
You know, for the mechanical one, this is a shabab also is very important for you. And don't be afraid that this course is going to the chemical direction. No, this is the combustion course that we are teaching, and it is taught actually in most of the universities. There is 2 to 3 combustion courses, undergraduate courses, core courses, and this is actually a main part. You have to know about that. This is something that is not additional for you in the mechanical engineering. You have to know about this, and you have to know about the combustion. Okay. طيب alkenes family يا شباب, which is the paraffin, it is actually saturated chain structure. Saturated means we don't have double bond, and it has the chemical composition CnH2n plus 2. Okay, N is the number of carbon atoms in the fuel, and it has يا شباب the suffix N, and depending on the number, the prefix of the fuel, we can decide about the fuel. Like when we say methane, when we see actually the fuel is ending with this suffix N, that means actually the chemical composition is CnH2n plus 2. Now when I say mess mean actually the number of carbon atom is 1, so N is equal to 1, that means H in this case should be equal to 4, and that should be CH4, which is the methane. And it has a shabab the chain structure. Like this also we can have butane. But see here in this table, you have to keep this in mind. But mean actually the number of carbon atom is 4. So for butane, if number of carbon atom is 4, then the number of hydrogen atom will be 10, because the chemical composition is CnH2n plus 2. But from where shabab I have known that the chemical composition is this one, because I said butane. I have seen actually the name of the fuel is ending with this N. So that means actually this is the paraffin family, and that should be the chemical composition, and it should be chain structure, and it is saturated. We don't have double bond in this case. We call it a shabab the normal one, which is a chain structure saturated. We call it N-butane. This is the normal one, a chain structure and saturated. We call it N-butane. But we may have isomer for this fuel. We may have isobutane. The same fuel, this is the same fuel, same number of carbon atoms, same number of hydrogen atom. But in this case, actually, we have replaced one of the hydrogen atom here with actually one of the alkyl group, which is the methyl group, CH3. Alkyl group, has the chemical composition CnH2n plus 1. Alkyl is ending with YL. So when I say methyl, mes mean actually the number of carbon atom is 1. And when you see actually methyl ending with YL, so the chemical composition is CnH2n plus 1. So that means if N equal to 1, that means H will equal to 3. We call this as methyl group. We can have a acyl group, C2H5. So CH3, we call it actually methyl group in this case. So it is, if you counted the number of carbon atom and the hydrogen atom, you will see them actually, they are actually the same, C4H10. But look here, the structure here, shabab, is different from the structure here. Still, it is a chain structure, but in this case, we have a methyl group is connected to the fuel. But what about higher hydrocarbon? So if I said I have let's say isooctane, okay? When I say iso, that means this is an isomer. It is a chain structure, but there should be some methyl group attached. But I don't know this methyl group is attached to which carbon atom. I don't know. So in this case, when I say isooctane, I don't know the chemical structure of the fuel, because there is methyl group, number of methyl group attached to the fuel, to the chain structure, but I don't know actually where those methyl group are attached to which carbon atom. So a more precise or sophisticated way actually to describe or name this fuel, we can say trimethylbentane. So let's write it here. When I say trimethylbentane, this is an isomer of isooctane. It is the same as isooctane. But let's see this, because I will ask you actually to write me down some fuel like this. I said trimethyl. Trimethyl, what does it mean, ya shabab? We have 3 methyl group. Bentane, bent mean actually the number of carbon atom is 5. Okay, so we have here those is 4, so those are the number of carbon atoms. And I said bentane, so we have a chain structure. All of this for the bentane fuel should be hydrogen atom, but it is not bentane. We have trimethylbentane. We have 3 methyl group connected to this bentane. But where we have those methyl group, he give here number 2, 2, and 4. That means for carbon atom number 2, we have one methyl group here, CH3, another one at carbon atom number 2, because he said 2 and 2, and actually carbon atom number 4. We start counting from the left side, Shabab. So this is 1, 2, 3, and the fourth one here, we have actually a third methyl group. And the other actually, we should have hydrogen at the other bonds in this case. This is a shabab, we call it trimethyl. We have 3 methyl group attached to the normal bentane. Bentane, we have 5 carbon atoms, and we have 3 methyl group attached. Then if you count this, it will be actually isooctane. It is actually an isomer of the octane fuel, and the octane fuel has the chemical composition C8H18. Bentane, this is actually C5H12. Okay, if we added C5H12 plus we have 3CH3, this one plus this one will equal to this one. So this is a more sophisticated way to just describe higher isomer of higher hydrocarbon in this case. I can just tell you about the number of carbon atom at which we have the methyl group and then attach it to the bentane normal chain structure in this case. Is it clear, Shabab? Is it clear?
Yes.
So, Shabab, please just try to interact. This is online. Just try to ask, try to do anything. So just to make sure that you are there. Yeah. So this is the first family, Shabab. We call it actually the paraffin family. There is another family, we call it monoolefin or alkenes. So this is alkenes, E-N-E-S. But this is alkanes. We have A-N-E-S in this case. Okay. The alkenes family has the chemical composition CnH2n. It is unsaturated. We have one double bond between the carbon atom, and it is actually of a chain structure. Okay, so we have one double bond, chain structure, chemical composition CnH2n, and it should ending with the name of the fuel should be ending with ENE. Like when we say ecene, when we see ENE, that means this is actually the alkenes group. The chemical composition is CnH2n, and we should have one double bond in this case. We have 2 carbon atoms, then the double bond will be in between. But what if the case of higher hydrocarbon? We have more than 2 carbon atoms, like when we say butene. In this case, I have to write down butene 1. Butene 1 means that we have this double bond after the first carbon atom. This is the case. This is the double bond, and it is of a chain structure, and actually the chemical composition is CnH2n. So when I say but means the number of carbon atoms is 4. And when I say butene, then it is CnH2n. So the number of hydrogen atoms should be actually 4 in this case. So it is C4H8. And I have to keep in mind this is actually, there is a double bond, and it is actually of a chain structure. Then I can write down the structure of the fuel in this case. Okay. The physical properties of alkanes and alkenes, both of them are very similar. They are almost, here we have only one double bond, so it is almost saturated. It is not actually activated to have chemical reaction with the medium in which it is stored, like actually the fuel tank in your car. Usually when we have alkenes, the fuel or alkenes, those actually fuel does not react with the gasket, does not react actually with the tank itself because they are almost saturated. Then in this case, they does not actually result in wear or attacking actually of those gaskets because they are already saturated. They don't need actually to get into more reaction. The olefin families, which are alkanes, they are also unsaturated chain structure, but we have either two double bond or one triple bond in this case, and it has the chemical composition CnH2n-2. And it is actually ending with dienes. So when I say heptadiene, diene, when you see this ending name, then in this case you have to realize that this is alkadiene group and its chemical composition is CnH2n-2. When I see hept will give us indication about the number of carbon atom, which is 7. That means you have to keep actually this table ya shabab in mind. Okay, when I say hept, that means the number of carbon atoms is 7 in this case. So heptadiene, so the number of hydrogen atom is 2n-2, so it will be 12, and this is the heptadiene. And we have in this case, shabab, we said we have to have two double bond or one triple bond. He said here we have 1 and 5 heptadiene. 1 and 5, that means we have one double bond after carbon atom number 1, and we have actually the other double bond is after actually carbon atom number 5. And the other connection are actually the hydrogen bond in this case. But the olefin family, shabab, all fuel or may have triple bond. That means actually it has a potential to react in order to be converted to saturation in this case. And that's why if it is used in gasoline or diesel engine, it should result actually in some deposit and also some accumulation on the fuel injector. And it adversely affect the injection process. And also it can result in wear. It can attack the gasket because it will be trying actually to be converted to the saturation mode or try to reach actually the equilibrium condition. Usually it is used, this olefin family, it is used actually in the industry actually of the synthetic rubber, in the manufacturing actually of the synthetic rubber. The other family is the naphthalene or cycloparaffin. Cycloparaffin, shabab, is, we call it cycloparaffin or cycloalkanes, or we call them as cyclanes. So when I say it has, first of all, shabab, the chemical composition CnH2n, but it is actually of a ring structure. Okay, it is not a chain structure, it is just a ring structure in this case. All of the carbon atoms are connected in a ring in this case, and they are connected to hydrogen atoms around. Like when we say we have cyclohexane. Cyclo mean this is actually the naphthalene group and its chemical composition is CnH2n, and the cyclo indicated is a ring structure. Hex mean actually the number of carbon atom is 6. And when I realize this is actually the naphthalene group, I have to keep this chemical composition in mind. That means H is equal to 2N, so it will be actually 12. So C6H12, and that should be actually the structure of the cyclohexane. If we have cyclopentane, pentane actually has the number of carbon atoms is 5, and this should be actually a ring structure. About 25% of the crude petroleum oil is actually naphthatic compound, coming from cyclohexane and cyclopentane. So this is actually one of the main components actually of the refining process. The last family, which is the aromatic group, which is the benzene. Benzene, ya shabab, is not the benzene fuel in your car. The benzene fuel in your car, this is actually isooctane. But benzene here is just actually have the chemical composition. It is a ring structure of chemical composition C6H6. It has actually 3 double bond and 3 actually single bond, one after one. You can look here, 1 single bond followed by 1 double bond, and they are forming actually the 6 carbon atom. And we have in this case the number of hydrogen atom are also R6. This aromatic groups, we call it the benzene derivative, forming either from benzene or we have naphthalene. Naphthalene is just two benzene actually ring are attached to each other. So in this case, the number of carbon atom is C10H8. This is actually, we call it the naphthalene We call it naphthalene. Even actually, this is a commercial name. We call it naphthalene. Naphthalene is just two rings actually of benzene connected to each other. If this benzene shabab is connected to one methyl group, we call it actually methyl benzene, or we call it toluene in this case. Toluene is a very very reactive material, highly reactive material. It is explosive material. Toluene is used shabab in some bombs, some kind of bombs. It is using actually toluene. And usually when they just manufacture a bomb or something, they may just add some toluene in order actually to have a lot of fire actually in this case. So toluene is methyl benzene. Ethyl benzene is also benzene, but we have one methyl group, methyl, which is C2H5 is attached to the benzene in this case. Usually those benzene shabab or aromatic family are derived through actually thermal cracking of the refining process, thermal or catalytic cracking at temperature about 650 degrees C from the refining process. But their main job, shabab, is just to increase. They are very good fuel additive to the gasoline fuel. If we added some benzene C6H6 to the gasoline fuel, it will raise actually its octane number. And that's why we have different octane number. When you go with your car to refuel, we have different octane number. We have octane number 90, we have 92, 95, all of that. The difference, shabab, is the additives added to the fuel. When we add benzene to the fuel, it raises the octane number. And the octane number, shabab, is a measure of the quality of the fuel. And it is a measure of the ability of the fuel to resist self-ignition in the gasoline engine. Self-ignition, if we have self-ignition, then we will have knocking, successive explosion inside the cylinder while the compression is strong. Then in this case, we will have noise. But if we have higher octane number, that means the fuel is resisting actually the self-ignition. It will not be ignited unless we have a spark plug. And that's why we use the fuel additive like benzene. Benzene is called actually it's a commercial name, we call it benzol. This is a very good fuel additive. We have to decide about the properties of the fuel. Then we can know about from the properties of the fuel which fuel is suitable for gasoline engine, which fuel is suitable for diesel engine, which fuel is suitable for gas engine or for the jet aviation. We have to know about the properties of the fuel before we decide actually which fuel can fit with a given application. So the general properties are the specific gravity, which is the ratio of density of the fuel to the density of water. Usually, shabab, the specific gravity is defined at a standard condition, which is 4 degrees C, because the specific gravity will be different at other temperature. But usually for the fuel, we use actually the test standard, consider actually this ratio of density of fuel to the water at 15 degrees C. Okay, so if you have combustion table or something, you will find them a little bit different from other thermodynamic table. The heating value of the fuel, shabab, is the heat content per 1 kilogram of the fuel due to burning 1 kilogram of the fuel in a theoretical air, theoretical or stoichiometric air. A stoichiometric air, shabab, or theoretical air is just the amount of air that can burn this fuel. We don't have excess air, we don't have less air. Just we have the theoretical, we call it a stoichiometric combustion. Just we have the amount of air that can burn this fuel without excess air, without less air. Because excess air, shabab, if we have excess air that can actually excess than the combustion process, this excess air will absorb a part of the heat due to the combustion and it will cool down the exhaust gases. If we have less amount of air, that means the combustion of the fuel will not be completed. Just will have some fuel is leaving the combustion process. This is the meaning of a stoichiometric. So in order to calculate the heating value or the calorific value of the fuel, we burn this fuel in what's called actually a bomb calorimeter. This is a combustion chamber. We just pass the fuel at 25 degrees C, burn it with air, and then the combustion product will be leaving actually this combustor. Then we can pass a water circuit around this actually combustion chamber so that the heat released due to combustion will be absorbed actually by the water. Then we can calculate the heat transfer to the water. It will equal to m dot Cp multiplied by delta T. Then we can calculate the heat transfer to the water. This heat transfer to the water, shabab, is the calorific value of the fuel. Is the heat due to actually burning this fuel. And this water, shabab, will make sure that the combustion products are leaving at the same inlet temperature. So in the bomb calorimeter, to calculate the heating value of the fuel, this is it's a kind of normal combustor. So we bring the fuel and we burn this fuel with air inside the combustion chamber here. This is the combustion chamber, and then the combustion product will be leaving here. The combustion products should be carbon dioxide, should be some water vapor, should be nitrogen, and some other component. This is a stoichiometric combustion. Due to the combustion process, some heat will be released in this case. Then we can, in this case, we can just pass here some cooling water around this. Actually, the bomb calorimeter. We have water is coming in, and this water is leaving here. So water out. So it will be leaving with water, tea water out, the higher temperature, and this is actually the temperature at the inlet, tea water in. So the heat due to combustion will be absorbed by the cooling water, and those combustion products will make sure that they are leaving at the same inlet temperature, which is here actually at 25 degrees C. So we have fuel plus air at 25 degrees C has burned, and the heat has been absorbed by the cooling water, resulting actually in rise of the temperature of the cooling water, and the combustion product now are leaving at the same temperature. Now we can calculate the rate of heat transfer to the water. It will equal to the mass flow rate of water, a specific heat of water, multiplied by the temperature difference, T water out minus T water in. Specific heat of water is 4.18 kilojoule per kilogram. Mass flow rate of water we can just calculate. T water out, T water in we can measure, then we can just calculate this heat in kilowatt, which is kilojoule per second. If we divide this actually Q dot, if we divide it by the mass flow rate of the fuel, then in this case we can calculate actually the heat in kilojoule per kilogram, which is actually the heating value of the fuel. So we just divide the heat transfer to the water, divided actually by the mass flow rate of the fuel. This is kilojoule per second divided by mass flow rate, which is kilogram per second, so it will be in kilojoule per kilogram. And this should be actually the calorific value of the fuel. Calorific value, Shabab, has two names, either higher heating value, we call it higher heating value, or lower heating value. Higher heating value when this H2O is in the liquid form. Liquid form, that means actually it does not have any kind of energy, it is liquid water. So the heating value in this case we call it the higher heating value. But if this water, Shabab, leaving the combustion chamber in the vapor phase, vapor, this means actually the water has been converted from the liquid to the vapor. That means it absorbed some of the heat. Some of the heat released here is absorbed by this water, and this water is leaving with this amount of heat. That's why the heating value will be low in this case. We call it the lower heating value. So lower heating value or higher heating value, usually the difference is not big. It is actually the latent heat of vaporization of water. So this is the difference. If the water in the liquid form, we call it higher heating value. If it is in the vapor form, we call it actually the lower heating value. Type flash point. Flash point, Shabab, is a point which is very important to storing the fuel. Like the fuel in your car, even in your car tank, we have to make sure that this fuel is below the flash point. Flash point is the minimum temperature at which we can have a combustible mixture of this fuel. Usually, in order to record this point for a given fuel, just we come up with the fuel, and then actually we heat it up very, very slowly, and then we can pass a fire at the top surface of the fuel. And then we continue heating until we reach a temperature at which actually there is a flash, just a small flash of not combustion, just a flash. So we call this point as the flash point, which is the minimum temperature at which we can have a combustible mixture of the fuel. And we have to make sure actually while storing the fuel, like gasoline fuel, diesel fuel, or any other fuel, that the temperature should be stored at a temperature lower than the flash point temperature. So that actually if there is any fire, this fuel cannot be ignited in this case. And that's why, Shabab, in winter, usually diesel fuel is a heavy fuel. So in winter, the diesel fuel car, usually they add some gasoline or kerosene to the diesel fuel in order actually to improve actually its combustion characteristic, because the diesel fuel is heavy and we inject it by the end of the compression stroke and we need it actually to start combustion immediately. So in this case, in winter, it becomes heavier. So in this case, we have to add some gasoline or some kerosene fuel to the diesel fuel in order actually to improve the combustion process. But please, Shabab, don't make this, because in adding gasoline or kerosene with a small fraction will result in much reduction in the flash point temperature. And this may result actually in explosion of your actually fuel tank. So don't make this. They are already doing this for you in the gasoline station and all of that. When you have the diesel fuel in the winter, in the very cold winter, this is not even in Saudi Arabia, okay? Because here, mashallah, the weather is doing well. But in some countries like Canada or something, they add to the diesel fuel some gasoline or some kerosene fuel in the winter in order to improve the combustion characteristic. And anyway, diesel fuel should be kept at temperature. The flash point temperature should not be actually lower than 55 degrees C. Type any fuel for any application should be purified. We should not have some water, because if we have water in the fuel, that will affect much actually the fuel injection nozzle, and it will result in wear, and it will result actually in changing the fuel injector in the engine after actually short period of running. Also, we may have some soot, so that we have to make actually that the fuel is light and it is clean. Also, we may have sulfur. The fuel actually should be containing the minimum amount of sulfur, ya shabab. Sulfur is not allowed in the fuel. We have to make desulfurization process in order to remove the sulfur, because sulfur, ya shabab, due to combustion in some situation, it will create actually with oxygen SO3. This SO3, if it is actually allowed to release the engine to the atmosphere with some water vapor, in this case it can be converted actually to the sulfuric acid H2SO4, and it should result actually in some what we call the acid rains in this case. So the sulfur content should be at the minimum level in the fuel. There are some properties that should be actually very important. Those are the general properties of the fuel for any fuel. But for the gasoline fuel, we have to be careful actually about some specific properties, like the volatility of the gasoline. Gasoline is injected in upstream of the intake valve. It has to be actually volatile enough, especially at the cold start of the engine, so that it can mix properly with air and it can start the combustion directly in this case. At 70 degrees C, shabab, we should have actually enough amount of this gasoline should be able to vaporize, be volatile at this 70 degrees C, at the cold start of the engine. That should be the engine temperature at the cold start. We should have about at least 20% of the gasoline is able to vaporize, so that we can initiate the combustion process. But we have to make sure, shabab, that this volatility is not too much. At the engine cold start, if the fuel is much more volatile, so significant amount of fuel in this case will be injected and it will be converted to vapor. But actually the engine does not need all of this fuel. So this vapor will stuck actually in the fuel line, and it causes actually the vapor lock. Vapor lock, ya shabab, is actually at the engine cold start, the fuel is volatile enough, more than enough actually, and more fuel is converted to the vapor phase. When it is converted from the liquid to vapor phase, it needs actually more space in this case, because in the gaseous phase need actually more volume compared to the liquid phase. So in this case, it will fill the fuel line with this vapor. So when the engine heat up, it will need more fuel. The fuel pump will try to pump more fuel, but already the line is already blocked due to actually with the vapor of the fuel that has been injected at the cold start of the engine. So the fuel should be volatile enough at the cold start so that we can start the engine properly, but it should not be actually much more volatile, because actually much fuel volatility at the engine cold start will result actually in vapor lock. Fuel will be vaporized and it will block actually the fuel line. So when the engine actually heats up, the fuel will be cut and the engine actually will be shutting down in this case. And also at temperature 180 degrees C, we should not have actually small amount of fuel, so that actually fuel does not mix with the engine oil in this case. Those are the properties شباب for general requirement for the gasoline fuel. This is the density of the gasoline fuel in gram per milliliter. It is 0.73, or it is actually 730 kilogram per meter cube. This is the density of the gasoline fuel. As I told you, it should be different from the winter to the summer. We should have some additives in order to improve the fuel performance in the winter. The anti-knock quality, which is the octane number, I will be talking inshallah in details about octane number next class. We have two kinds of octane number: research octane number and the motor octane number we'll be talking about in this case. And this is يعني شباب the test standard, the code of the test standard that is used to calculate this test. Okay, so yes, go ahead مصطفى.
ايش الفرق بين البتروليوم غازولين regular?
Regular one, but the premium one is the better one.
Oh, premium.
Premium. Regular one is just يعني the normal one. We can say this should have more additives and it should be a little bit more expensive. Yeah. Okay. Inshallah, شباب, we'll be talking about the fuel quality, the octane number, the difference in octane number, and why actually it is the difference if we have fuel of lower octane, fuel of higher octane. What is the difference in this case for your engine? And also, if you have all the virgin car, does it need actually to have higher octane number? I don't think so. So like some many cars in Egypt, if you look there are many older cars. I think here you don't have all the cars. That's why octane number here, when you go to the gas station, you will find it either 90, 91, it could be 95, something like that. But you will not find 80. 80 octane number is existing in Egypt, but it is used actually in very old car, and it is used in different locations in the world. If you have all the virgin car, that means already the compression ratio is small, so will not have self-ignition. So it doesn't matter if you use actually higher octane number or not. The lower octane number will do the job. Okay, I will be talking about this يا شباب إن شاء الله. And this is the sorry.
احنا اللي عندنا موجود 95.
There is yes 95 and there is even 98. يعني but 98 usually the car manufacturer. They don't like actually to manufacture their car to work with higher octane number, because higher octane number that mean actually it is higher price for the fuel.
زين احنا نقدر نعتبر ال 95 بريميوم ولا ريجولار؟
It can be, it is regular. You can look here. Premium we can يعني consider it at about 98 or something. Okay. But it is 95 is premium, يعني is we can consider it, yes, it is premium fuel.
Okay.
Very clean fuel. But it depends يعني شباب. Do you need 95? So don't go to the gas station. I will talk about this inshallah next time. When you go to the gas station, just find 95 looks red and that looks better fuel. Why not go for 95? So this is something that we'll be talking about. Is it actually, do I need it? Actually, my car, if I go with a given car, it is better actually to take actually 80 gasoline, but actually this is for the old virgin car, octane number of 80, very small octane number. But the car is old and it already does not have efficient combustion or high pressure combustion. So lower octane number will do the job in this case. So inshallah, we'll be talking about this next time, inshallah. The sulfur content, ya shabab, and the evaporative component, all of this actually should be at the minimum level in the fuel in this case. Vapor pressure, shabab, this is the last point here. I will stop here. Inshallah, next time I will be talking about the octane number and the engine knock. Vapor pressure of the fuel should be, shabab, should not actually drop below a value of 0.7 bar. So that actually the fuel does not vaporize and cause vapor lock at the engine cold start. Okay. Usually they have some alcohol fuel to be added to the gasoline fuel in order to improve its performance and its octane number. We can add some alcohol, but usually using alcohol is not preferred at the engine startup, because this alcohol will be vaporized in significant amount and it will cause actually what we call the vapor lock, that the fuel will be vaporized in the fuel line and it will block actually the fuel line once the engine heats up. Okay, is that clear, Shabab?
Yes, very clear.
So, inshallah, today we are done with this class for today.